Yes, good morning everybody. So coming to VHDL language basic elements. In previous sessions we have seen the identifiers, data objects, data types. Now we are going to discuss one more basic element is that is operators. So what are the different operators available in the language in order to do various operations like logical operations, arithmetic operations, comparison operations, like that. Okay. So first of all, what are those operators available in the language? That list we can observe. After that we will discuss each and every one with the examples, right? Uh, actually, of course, okay, before going to discuss these operators, see once the example on the data types and data types and data objects. Okay. First of all, for every VHDL program. So previously we have seen an identifier, data types, data objects. What are the syntaxes for those? Uh, and with some examples we have seen, and now how they can use in the program, that we are going to see with this example. Okay. So first of all, for every program you know that you have to write the library IEEE. So because this is the standard library, you need to open it. Then from this library you need to choose one package, that is standard logic 1164. Standard logic 1164 is the package. So from this package you need to put all the definitions whatever this package consists. So that's why dot all. So how can you open this package is use library name, that is IEEE dot standard logic 1164 dot all. That means all represents all the declarations or definitions whatever this package has, they can be now acceptable to our program. Okay. Followed by this entity writing. So writing the entity or entity declaration. Already you know the entity includes both input and output ports. So here is one entity declaration with the name vector definition. That is the name given. So this is as per textbook I am giving here. So entity, name of the entity. Okay, entity name, it is user defined name, right? Is port of. So here four ports are there, four ports. First one is num1, number 1. Okay, it is in at the mode in, so that it is input to the digital system. It is input to the digital system, and it is declared as a vector. It is declared as a vector through standard logic vector. Standard logic vector is a predefined data type. Already you know the standard logic consists 9 different values. Okay. And now it is since num1 is declared as a vector with how many locations? 7 down to 0. That is num1, number 1 can accept 8-bit data. 8-bit data. What the data values are? Whatever the 9 different values the standard logic consists. So usually the binary data. And 3 output ports this system has. One is named as register 1, and another one is register 2, and third one is register 3. So what is the difference between these three? Register 1 is just declared under data type standard logic. So it accepts only 1-bit data. Whereas register 2, it is declared as an array of size 3 down to 0. That means it accepts 4 bits only. 4 bits, that to 3 down to 0. Whereas register 3 can accept 8-bit data 0 to 7, that is 8 bits. So and entity name. So this is the entity declaration for the given digital system with the name vector definition. Okay, following. Okay, this system has one input, that is 8-bit number, and 3 outputs. That in 3 output case, register 1 output is consisting 1 bit, register 2 consists 4 bits, register 4 consists 8 bits. Okay, that is the information from the entity declaration. Coming to architecture body, so as the syntax for the architecture body is, it start with the word architecture. It start with the word architecture, then architecture name, that is here what is the name given, data flow model of entity name, that is vector definition is. Okay, so as per the syntax of the architecture, the first line has written like, it start with the word architecture, then architecture name, that is user defined name, it is an identifier. Okay, here name is data flow underscore model of, this is the entity name. In previous slide we have seen the entity name for the given digital system, that is vector definition is. Then begin means, directly begin means there is no declarations, internal declaration, there is no internal declarations, that's why directly begin they have written. Okay, so after begin, so what information it has, just assigning the input values, the input 8-bit number, okay, with different sizes at the output. Okay, because the output has three different cases, one is register 1 and second one register 2 and third one is register 3. Okay, so in first one case what will happen, a selective location data is assigned to register 1. Okay, selective location data. Okay, which location, location 2. Okay, or position 2, position second bit position, second bit can say some 7 down to 0 means, 7 down to 0 means, okay, in second bit position what is the value is there, that value is assigned to the register 1. Coming to another one, that is second register 2 assigned with num1 7 down to 4, that is MSB 4 bits. MSB 4 bits are assigned to the register 2. Whereas register 3 equal to num1, register 3 equal to num1. So register 3 is a 8-bit vector, num1 also 8-bit vector. So all 8 bits can be assigned to the register 1. In first one case selective bits, in last one case all bits, but in the last one case the order is different. Why? Because register 1 is declared as 7 down to 0, but num1 is assigned as 0 to 7. So the order is different. Okay, that is the MSB bit of input number can be occupied the LSB bit at the output. Okay, the order is changed in reverse order. Okay, the order is changed as reverse. Okay, so like that the vector data objects, data types, so and assignments all are represented here, not all, some represented. Okay, here the data objects register 1, register 2 and register 3 are called the signals. Why? Because they were declared in the entity itself. Okay, whatever the object declared in the entity, they are by default considered as a signals. Okay, and also you can observe here, so some 3 statements starts with the 2 hyphens. Okay, 2 hyphens. The 2 hyphens represents the after 2 hyphens whatever the information is there, that is treated as a comment. Okay, that is comments start with the 2 hyphens. Okay, then finally end architecture name, that is data flow model. Okay, following. So this is the example I have chosen for the usage of signals and declaration of arrays and their assignment to the outputs like that. Okay, I think this example is for somewhat how the objects and data type. Here data types are 2 data types you can observe. One is standard logic and another one is standard logic vector. Okay, in single bit case standard logic is enough. In vector case, that is if you want to assign more than 1 bit case, standard logic vector you have to use with some range. Okay, with some range information. Okay, so like that some data types uses and signal declarations. Okay, identifier, of course identifier is the name to the signals and name to the entity, name to the architecture, right? So like that, some data types and data objects uses we observed here. Okay, then followed by it here, we have one test bench also is available here, one test bench. I said that test bench also a VHDL program. It is used to verify the results of the original program, main VHDL program. Okay. So since it is also a VHDL program, also uses the library like IEEE, use IEEE.standardlogic1164.org, and an empty entity declaration. So entity vector definition TV. That is, this is an entity related to our entity. This is a test bench. This is a test bench in the entity related to our program entity. Okay. So after that, architecture definition. Okay, in the architecture case, you need to define all the ports whatever you have in the entity, main program entity, they are declared with the signal, and the entity part of main program will be declared as a component. Okay. So first, if you observe here, architecture name is data flow of vector definition TB, that is entity name. Okay, here architecture name is data flow of entity name is vector definition and TB is. Then what I said in the declarative part, main program entity declaration declared as a component here. Okay, main program entity declaration declared as a component. Okay, so without any change, only changing is instead of entity word here component is used, that's all. Okay, similarly all these signals, num1, register 1, register 2, register 3, so for this 4 you need to declare internal signal using the keywords like signal in 1 and signal out 1, signal out 2, signal out 3. Okay, here these are the names given with reference to how many ports in the entity declaration are there or in the component declaration. For them internal signals we have to declare. Using the word signal. Okay, then begin. Then after that, instantiating the unit under test. That is begin, that is instantiation statement, UUT colon, component name, vector definition, port map of. Now you need to relate the internal signals to component ports. Num1 is linked to in1, register 1 linked to out1, register 2 linked to out2, register 3 is connected to the out3. Like that, a named association you need to mention in the instantiation statement. Okay, then the step in the test bench is applying the inputs. Okay, or providing the inputs. How can you provide input? That is through process statement. Okay, so process begin, wait for 5 nanoseconds, some delay you need to use. Okay, wait for 5 nanoseconds. Then in 1 equal to some 8-bit number we assign. Okay, in 1 equal to some 8-bit number. Again wait statement you can use or not. Here it is also a comment like they placed. Then end process and architecture name. Okay, so like that we will apply the input data or we will provide the input data. Okay, so after that, if you simulate, you can observe the output in the form of timing diagram. You can observe the outputs. Okay, so outputs like register 1, register 2, register 3 data we will observe. Okay, so like that the example we can take in order to show the usage of data types, data objects, identifier, etc. Okay, thank you. Actually I started this class for explaining the operators, but maybe in the next class, class, okay, I will explain the operators. Okay, thank you.